Hello guys. Last time we considered this practice question, brain teaser question. This is about the number of cancellations among 10 reservations, and I asked what is the probability that 2 reservations are canceled among 10 reservations, and the respective for each reservation, the probability of cancellation is 10% equally, and they are independent. Then we know the answer. The answer is 19.37%, which seemingly has nothing to do with any of these numbers. 10 reservations, 10%, 2 reservations. Then where is that number from? So last time, to understand this number, why we got this number, we are going to study these 6 steps from the simplest to the general case. So we learned what happens when there are 2 reservations and 3 reservations. Just to review, we considered first thing you have to notice here is that I asked first question as what is the probability that A's reservation is canceled but B is not? There are only 2 reservations, A and B, and you know that A canceled but B does not. Then what is this probability? It is easy using independence. It was simply zero point 0.1 times 0.9. 0.1 came from the probability of cancellation for A, and 0.9 came from the probability of not canceling the reservation for B. So 2 events are independent, so they are multiplied. But when I tweak the question in this way, so now we are looking for the probability that exactly 1 reservation is canceled among the 2. Then what is that probability? Now this is different. In the previous question, the answer was 9%. This is 9%. But now when I say just 1 reservation canceled, its probability becomes 18%. The probability doubled. The reason is because I don't know who canceled the reservation. What we know is there are 2 reservations and one is canceled and the other is not. But another problem is it could be A and B, or it could be A and B. So the cancellation could be from A or B. We have to think about 2 different scenarios. So, and each scenario has 9%. So if A canceled, that is 9%. If B canceled, that is another 9%. So as a whole, the probability of 1 cancellation is 18%. Remember, if you make a 2 by 2 table, there are 2 outcomes that satisfy y equals to 1. In these 2 outcomes, the number of cancellation is 1, so you have to count two outcomes for that event. When we extend the probability, the number of reservations to 3 cases, then the idea is the same. Now we have to consider 8 different combinations, and among them, only these 3 cases have 1 cancellations. So when I say if we want to calculate the probability that only 1 of 3 reservations is canceled, then you have to think about these 3 outcomes among 8 possible different combinations. So we focus on these 3, and so we have the 3 outcomes in the same event, and interestingly, each of the outcome has the same probability. So in the end, we have some probability. So 0.1 is probability of cancellation, and 0.9 is the probability of non-cancellation, which happens twice, because what we know is there are 3 reservations. 1 is canceled, the other 2 are not. So the canceled reservation, its probability is 0.1, and the other 2 has probability of 0.9. So zero point 0.1 is and zero point 0.1 times 0.9 times 0.9 is the probability of single outcome. But there are 3 outcomes with the same probability, so you multiply 3. This was a brief review of what we have done in last week, in the last week's video. So now compare. Let me extract the essence of what we are doing here. What we want to see here is what I want to show you here with these 2 examples is that the probability y equals to 1, probability y equals 2 in both cases consists of 2 parts. We can think the probability in 2 steps. First, you have to think about how many outcomes satisfy that event y equals to 1. So what we know is one reservation is canceled, but there may be different combinations because you don't know who canceled it. So depending on who cancels the reservation, there could be different scenarios, and you have to count how many different scenarios included in this event. That's the first step. And in the second step, okay, then like if there are 2 or 3, there are several outcomes included in the same event. Then for each of them, you have to calculate their probability. But as we saw in the previous derivation, they are the same. The probability of a single outcome is the same across all the outcomes included in the same event. So it does not matter the probability. So we will study the second part first. So this is how we calculate it. So when you have 2 reservations and only one of them is canceled, then we have to think about 2 outcomes like this. When there are 3 reservations and one of them is canceled, we have to think about 3 outcomes. And basically the probability is easy to calculate because we assumed independence. So the A and B are independent, so simply you can multiply the probability of each reservation. Then the point is, what we can see, the pattern here is that in any case, 0.1 is the probability of cancellation, and 0.1 is multiplied as many times as cancellations. In those cases, in all of these examples, we assumed cancellation happens once. Only one of the reservations is canceled, so 0.1 is multiplied only once in all cases. And then 0.9 captures the probability of non-cancellations. So 0.9 should be multiplied as many times as non-cancellations. So when there are 2 reservations and one is canceled, then automatically there is only 1 reservation that is not canceled. But when 3 reservations, one of them is canceled, so automatically 2 reservations are not canceled. So in this case, 0.9 is multiplied twice, right? And finally, these 2 probabilities are the same. These 3 probabilities are the same. So it doesn't matter. The probability does not depend on who cancels. In the end, everything is independent and all the probabilities are the same for everyone. So in the end, it does not matter if it's A or B. But in the end, we have to sum them up. That makes the question, the problem much easier. So remember these 3 key ideas. You multiply the probability of cancellation, probability of success as many times as the success happens. And of course, the probability of failure must be multiplied as many times as the number of failures happened. And finally, it doesn't it does not matter who succeeded and who failed, but you have to count the different combinations. Just what matters is just the number of combinations, not exactly who succeeded and who failed. Okay, make it generalize. So there are n trials, or in our example, it means reservations. And P is the probability of success, as we assumed at the beginning of binomial distribution. So P is probability of success. In this example, success is cancellation because we are counting the number of cancellations. So what we count is success. And we are calculating a probability of the number of success equals to a certain number. And we choose 1 here. We used 1 for this value, but it could be 2 or whatever. It could be 0. It can be any number. So in this general setup, generalize that, then the probability of one outcome, a single outcome included in this event, can be summarized in this way. Probability of success is multiplied y times, because I'm asking you the probability that number of success equals to y. So success happened y times. Then if success happens y times out of n trials, that automatically implies there are n minus y failures. So the probability of failure is multiplied n minus y times, right? That's intuitive, but it's just one of two steps. It's just one step. Now we have to think about how many different outcomes are included in this event. That is, like when you have 2 reservations, 3 reservations, it's easy. Just you can think about when 1 reservation is canceled, then it's one of the 2, so there are 2 different cases. Or when there are 3, it's one of the 3, so there are 3 different cases. But now, in the next video, what we are going to consider is we will consider 4 reservations, and we will calculate the probability that 2 reservations are canceled. There are 4 reservations, but some 2 are canceled. It could be this 2, it could be this 2, it could be this 2, and there are many different pairs. You can choose different pairs. And how can you count them? Can you just list? Do you have to list all of them? So that's we are going to generalize the pattern in counting the number of different combinations. Okay, and see you in the next video. So far, the first video is a summary review of the previous materials. Thanks for watching. See you in the next video.